Given the following three-step reaction mechanism, write the equation for the overall reaction and label the catalysts and intermediates. So if we add the molecules on the left and right, and cancel out those that appear on both sides, we obtain the following overall reaction. And here, C and D are the intermediates, because they're produced and then consumed in a subsequent step. And here there are no catalysts, because catalysts are consumed and then regenerated in a subsequent step. Now write the rate law for the reaction, assuming step 2 is the slow step. So we can write the rate law as follows, using the stoichiometric coefficients of the reactants in an elementary reaction. And this is not our final rate law because C is an intermediate. So here we'll use the pre-equilibrium approximation because the first step is faster and we can assume that equilibrium is reached quite quickly. So in the forward direction, the rate at which A and B are consumed is equal to the rate at which C is consumed in the backward reaction. And now we can solve for the concentration of the intermediate. And then substitute this into the rate law. And this here is just another constant, so we can replace it as follows. Now in part C, we're asked to determine the units of the rate constant. So using dimensional analysis on the rate law, molar cancels, and then if we divide through by molar squared, the units of the rate constant are molar to the -2 by seconds to the -1.